Hi. So the simulation, the whole program wasn't working on my computer, so I just had a friend send me a picture, a screenshot of theirs. So I'm just going to explain like what the program shows and all of that. So here, on the right, maybe your left, I don't know. There's a graph here that gives you that shows you the amount of kinetic, potential, thermal, and total energy. However, we're not going to be looking at thermal energy, so well, at least not yet. Um, in here on the right, just kidding, on the left, or my left side, is the actual like curve. Where is the mouse? Oh, here it is. Okay, so you have this skater, and he's like on a ramp. It's this curved line, um, on its track. Also, up here you have the choice to select this what kind of skater you want, which also has an effect, as I learned later. You get to choose what kind of skater, measuring tape, potential energy reference. There's a grid because you can also change the actual track. Um, and yes, you can also change the location. So you can go either to the space, moon, or Jupiter, or stay on Earth. Okay, so kinetic energy has to do with how fast the skater moves and basically kinetic energy highly depends on the skater's motion. Potential energy, however, has to do with gravity fields. Gravity fields are a part of the system, so that's very important to consider. Um, Potential energy is also known as gravitational potential energy. Um, together, together, kinetic and potential energy make up the total energy that we see. So, they kinetic. Well, I'm gonna go over. So, if this skater were to press play, the skater would be going up and down the ramp, his own track. So, as like when right now the skater's at the peak of the track, so he's almost about to fall off, but he doesn't. And when he's at the top, you can see on the bar graph that potential energy is at its highest. So, as the skater's towards the total end of it, the potential energy is the highest it will go. And in turn, once the skater is going down the ramp and you see him actually moving down, kinetic energy is going to increase a lot as well. And together, kinetic and potential energy will make up the total amount of energy of the system. So, one thing to consider is that kinetic and potential energy are both directly correlated with each other. So, if kinetic, if well, they're not directly, but they're kind of like oppositely correlated. So, if kinetic goes up, potential goes down. If potential goes up, kinetic goes down. So, and that we can totally verify with how the skater goes up and down the gaps and how the bar graph changes in response to the skater's motion. Um, also, the mass of the skater also has a lot plays a huge role in this whole system. So you can choose what skater. I think you have between this skater. There's a girl dude skater. There's also a bulldog, and then there's a ladybug or a bug that's like 0.2. Its mass is tiny, so I don't really remember the masses, but I do know that the masses do vary. So the mass of the skater that you choose affects the bar graphs. So like if I were to click the bug, the potential kinetic energy will completely decrease. It'll be very tiny. You can barely see it, or you can barely see. You have to like zoom in. So that really does play into effect. That's something I did not know um, until I played around with this whole simulation. Um, yes. Also, when you change the location of the skater, the skater's the entire system is kind of like flipped upside down because now, like when we took it, I think when we took it to the moon, we let the skater go off on its total potential energy, and as I was reaching the top, and the kinetic energy was slowing down, the skater actually fell off the ramp. So that's something to really consider. So it totally depends on your location because then that changes the variables that you're implying to your system. Also, sorry. Also, when you move the skater up and down, it changes the total energy. So as you move it, it's directly correlated with the bar graphs as well. So that's just also reaffirming that. Also, if I were to click the dotted line where you can actually see your reference point, dotted line would be equivalent to 0. You're kind of setting a reference. So where you decide to place the dotted line, that will also play a part. in your grasp and the total energy that's being described and portrayed. So yes, that's skate park energy.